Even for an expansionist species like us, Mars is extreme. At first glance, Mars seems familiar. Polar ice caps, large valleys, liquid water under its surface, and a day barely longer than Earth's. The ideal place for us to go. Unfortunately, Mars is actually a cold, radioactive desert where the ground is poisonous and breathing is impossible. Mars is awful. You almost certainly don't want to go there. The pioneers doing the hard work on Mars will have an intensely stressful life filled with incredibly challenging problems never encountered before. But there are plenty of people willing to do that work, and we have the technology to enable them to do it. For this video, we will assume there have been prior missions to Mars to scout out a good place for an outpost, store resources and equipment, and that there's already a moon base that serves as a hub for Mars missions. The first major challenge for our outpost is the fact that Mars is very energy poor. Because of its distance from the Sun, solar power is only 40% as effective as on Earth. But even this weakened sunlight is often obscured for days by enormous dust storms. Solar power alone will probably not be enough. Alternatives such as wind power and geothermal energy are also unfeasible, as there's hardly any atmosphere and Mars's interior is much too cold. Initially, nuclear technology might be the only option. Since Mars doesn't have easily accessible radioactive elements, the nuclear fuel needs to come from Earth along with the reactor. If we do set it up, it could power our small outpost for the first few years. Unfortunately, all that energy won't be very useful if we can't breathe. Mars's atmosphere is only 1% as dense as Earth's and mostly made up of CO2. So our habitats need to be pressurized and filled with an artificial atmosphere made of nitrogen and oxygen, which comes with more problems. Corners and flat walls are weak points, so the habitats will have rounded and smooth shapes to handle the stress of great pressure differences between the interior and exterior. The airlocks need to be very airtight and work perfectly every time. Without an extensive magnetosphere or a dense atmosphere, half of all radiation coming from space reaches the ground. A person on the surface would be subjected to 50 times the radiation that they would be on Earth. 3 years on the surface of Mars exceeds the radiation dose limits imposed on NASA astronauts for their entire career. This increases cancer risks significantly,